going to do a Bible lecture, but I'm going to do a little different today. I'm going to leave God out of our discussion. Because ever since the world began, man has always marveled at the beauty, the order, the systems in creation. The specialized ability, you look at any animal, I don't care if you take an ant or a bee or a bear or any big or small animal, every animal has its own distinct characteristics and its own unique abilities. It's really dumbfounding when you look into them. Each has an intricately designed behavior pattern that would seem to tell us that there's a wise master builder behind the whole scheme. And you ask, well, could this have come about by natural selection, just by chance, just the way nature turned out and to make it turn out that way? Now, we all know from our own experiences that things work out much better if you plan it than if you just go by chance. But today, like you say, even though we're here for a Bible talk, I'm going to leave God out and pretend there is no God when it comes to our discussion about the earth and the animals that are on it. That's what most scientists teach, that life as we know it on this earth came about not through the work of a divine creator, but it came about by chance. So let's assume they're right. Let's look at the feasibility of evolution. What are the chances of that being right? That things just happen because that's the way it had to be, that's the way it should be, and so that's the way it turned out. If that's true, cats around here should stop hunting and learn to open a can of cat food pretty soon. But anyway, the more science discovers about plants and animals and about the universe, the more utterly amazing it becomes. So marvelous are these works of creation that the evidence of a master plan and builder is overwhelming. Not only due to the likelihood that things in nature couldn't happen like this without a plan, but even more so when you look at it, it appears to be planned. We see the same pattern over and over. And let me give you an illustration. Jace, a couple of weeks ago, you handed me a deck of cards and you asked me if I would shuffle the deck for you. Okay? Now, if I went into the other room and came back a couple of minutes later and handed you your deck of cards, and you took the first one and it's an ace, 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 king, 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 queen, what would you think? You think I did a good job of shuffling them?
No.
Okay. Rachel, why do you think he would not think I did a good job of shuffling them?
Because they're all in like an order.
Okay, and if I shuffled them, you would expect random, right? You wouldn't expect to see any kind of an order in them. Well, they have to turn out in some order. Why not turn out in that order? Couldn't it happen? That's what the scientists have us build. It's got to happen. Some order's got to come out. Maybe it came out in that order. When we look in nature, we see, just like the deck of cards, we see the same system, the same order, over and over and over again in the different structures. Whether we look at the structure of an atom with its center and its satellites around it, or we look in the universe with the Milky Way, with the sun, with its planets around it, or we look in the whole solar system, we see that same kind of consistency, the same order, ace, 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 king, 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 over and over again. Maybe it just happened that way. Cards have to be in some order, so why not in that order? Well, what are the chances of you handing me that deck, me shuffling it, and it comes back right in that order? You ever think of, well, it's got to be in some order, maybe in that order. The chances of it coming out in that order 1 in 80 million, 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 million chances of that turning out in that order. It could, but it's not likely. Now, that's with 52 cards. What if we took 2 decks and we decide to shuffle 2 decks together? Well, when you put another factor in that, you don't double the chances of it not happening. It's multiplied. Let me give you an illustration. If I said 1 in every 10 men have a beard. Okay, so you see the chances, you get 10 men, the chances are 1 of the 10 would have a beard. And if I said 1 in every 10 men have a blue suit on. So once again, you get 10 men, you would expect 1 out of the 10 to have a blue suit on. But what are the chances of finding a man that has a beard and a blue suit? It's not 20, you don't double the odds. You multiply 10 times 10, it's 1 in 100. Because if you have a group of 10 men, you'd say 1 of them has a beard. Another group of 10, 1 of them has a beard. You did that, you got 10 groups. Now you have 10 men that have beards. 1 of these 10 men should have a blue suit on. So you need 100 people instead of 10 because we introduced a second factor. So if we take our 52 cards and we take 2 decks, now it's 1 in 80 million, 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 million times 80 million, 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 million. That's the chances of 2 decks coming together that way. Now we look out in nature, we're not talking about 52 variables. We're talking about thousands of variables, all kinds of chemicals and elements coming together. And it comes together in the exact same way every time. What are the chances of that happening? You find it over and over and over again in nature. So let's just assume, once again, that there's no God, and take an ordinary wristwatch to show my illustration. You look at the gears and the little springs and the levers and stuff, and you look at it and you say, somebody designed it that way. But if it just came together by nature for no reason, the watch didn't know why it needed to keep time, but for some reason it decided it needed to keep time, and it knew it needed all these parts, so all these parts came together and started working together because that's what it needed to do. And you take your eye, your ear, any part of your body, much more complicated, much more intricate than a watch, and yet we're told these pieces just came together and worked that way because that's the way it had to do it. And yet it's much more complicated and much more intricate than even a watch. So it's kind of really stupid to say, well, it just happened by chance. So let's see, we'll assume there's a creator, but let's assume that it's not God. Let's assume that we're a creator. How would you go about creating something like an Earth, or a solar system, or the universe, or even a simple ant or a honeybee? How would a person go about creating these kind of things? Well, let's start and create the universe. First, we'll need a source of heat. You need power. And so we'll invent nuclear fission. And then we'll create stars that use this nuclear fission. Not just stars on a small scale, not just a few million stars, but I'm talking about millions and millions of star clusters, and each one of those clusters will have millions and millions of stars in them, billions of stars in them. Okay? And after we've created that, we're going to take one star, and it'll be a very small star compared to all the other stars that we created. This one small star is only going to be 1 million miles in diameter. That's the size of it. Now, there's other stars much bigger than that. Like Job mentions, he says, "Canst thou bring forth Meseroth in his season?" Now, this star that Job mentions is over 1 million times bigger than this little star that we created. But we're going to start with just this little star. It's 1 million miles in diameter, and we're going to call it the Sun. Okay, it's one of those small stars. And we're going to have this travel through space at 900,000 miles an hour. And we're going to make it so that every year it's in the exact perfect location with every other star, the billions and billions of stars in our solar system, in the universe. It's going to line up perfectly with all the other stars so that every year it comes out exactly in the same place as every other star is doing. All these billions of stars are all rotating around at thousands of miles an hour, and they all end up exactly in the same space year after year. So perfect will it be that a ship out on the ocean at night can look up in the stars and pinpoint its position on the Earth by looking at these stars that are billions of miles away and traveling at all this high speed. But it's perfect timing so that they can tell exactly where they are. And they're going to do this century after century after century and not miss a beat. And so precise is the sun going to be spinning around that we will know the days and the nights and the months and the years. We can set our watches by a sunrise. We know when it's going to come up. We know when it's going to set. It's going to be perfect year after year, even though it's big body spinning around like that. And God said, "Let there be lights in the firmament of the heaven to divide the day from the night, and let them be for signs and for seasons and for days and for years." The fool hath said in his heart, "There is no God." But let's go back to this small star that we created, the sun. It'll be hot. We're going to make it, this nuclear fission is going to be hot. The external temperature we're going to make between 6,000 and 7,000 degrees. Okay? But the internal temperature of the sun is going to be 50 million degrees. And then we'll have the sun alive with active storms. It'll have these fiery sunspots with great hydrogen flames shooting out from its center. And they're going to shoot out 20,000 miles out of its center, these big hydrogen storms in all directions. And then near the edge of this 20,000 mile hydrogen storm, we're going to make a bright ridge, and that's what gives the sun its brilliance. These are going to be 40,000 miles long and about 4,000 miles wide, each one. So now we've got this one small star created. Now we're going to go 93 million miles away through space from that star, that sun, and we're going to make a very small blob of dirt here, okay? Dirt and stone. It's going to be very small. Even compared to our small sun, it's going to be 1 million times smaller than our sun. It's going to be really small. It's only going to weigh 600 billion ton, okay? And we're going to call it the Earth. And we're going to make it spin through the sky at 18.5 miles a second, which is 110,000 miles an hour. And so this Earth, like all the others, things that we created has got to hold its timing perfectly. It can't wobble, it can't vary. Even a fraction of a degree, if it just turned a little bit, it would end up in disaster. It's got to stay perfect in time with all the other stars and objects that we created, or else we'll have disaster as a result. The distance from the sun has got to be just right. What happens if it gets too close? It would be too bright here, it would be too hot. Nothing could live. Or if it got a little bit too much further away, everything in this earth would freeze solid and it would get dark. And so we have to have it precise temperature at any point on the earth within a few degrees. All this from 93 million miles away. That's our heat source. So exact are we going to make this? If you go to high Texas this summer, you know what the plan. You know about what the temperature is going to be in Texas in July. Or if you go up to Alaska or to a Richard study weekend in December or January, you have a pretty good idea what the temperature is going to be at that time. Or if you come down to the October gathering here in Boston, you pretty much know what the temperature is going to be here. It's going to be so exact that you're going to know. It doesn't matter what time of year or what part on the earth, you'll know what temperature it's going to be. This year, next year, 20 years from now, it won't matter. You'll be able to figure out how to dress because you'll know what the temperature is going to be. It's got to be right. It's got to be exact. If it was a little bit further from the sun or a little bit closer, disaster. It's got to be just right. All the other bodies that circulate the sun have extreme temperatures. When the planet gets on the one side of the sun, it freezes way, way, way below zero. And when it gets on the other side of the sun, it gets extremely hot. But on the Earth, we're going to maintain a consistent temperature. Now, why is that? Well, we'll make a mantle of air. And we'll surround the Earth with this mantle of air. We'll call it the firmament. And it will protect us from the sun's rays. When the sun shines on the Earth, the atmosphere is going to protect us so we don't burn up and cook. It's also going to protect us from the daily bombardment of millions of asteroids and things that are flying around. It's going to come down to the Earth. We'll have the atmosphere, so as soon as it enters the atmosphere, it burns up so that it won't hurt us here on the Earth. And we're going to have it the right mixture of gas, say 29.9% oxygen. If you had more oxygen than that, you'd get oxygen toxicity and your lungs would be destroyed. If we had less oxygen than that, we wouldn't have enough oxygen to function, and we wouldn't, depending on how low it goes, even down to 17%, then you have problems. So we'll have to have it keep exact right combination of gases in this firmament on this Earth that we created. And we'll have this as one of the things that are circulating around the sun, that's circulating around the solar system, that's circulating around the universe, all going at different speeds, millions of miles an hour, all in perfect timing with each other. Could we picture ourselves as a creator and doing this kind of stuff? How does one go about doing this? Doesn't it have just the opposite effect on us? To make us feel small and insignificant, realizing that, boy, we're really nothing. David says, O Lord, our Lord, how excellent is thy name in all the earth, who has set thy glory above the heavens. When I consider thy heavens, the work of thy fingers, the moon and the stars which thou hast ordained, what is man, that thou art mindful of him, and the Son of Man, that thou visitest him? It says, the heavens declare the glory of God, and the firmament showeth his handiwork. Day unto day uttereth speech, and night unto night showeth knowledge. There is no speech nor language where their voice is not heard. Their line has gone out through all the earth, and their words to the end of the world. Just look around. I don't care what language you speak. I don't care what language you understand. You look at the earth and you see evidence of God's handiwork. There is no voice. There is no language that their voice is not heard. Do we hear their voice? Do we understand their language? Do we understand there is a God, there is a Creator? If not, why not? How come we can't understand this? But let's go a little further in our imagination. Leaving God out and imagining ourselves to be a creator. Only, we've been talking about such big things. Let's talk about something small, something easy. Maybe we should try something simple that we're familiar with, the old honeybee. Now, I'm not talking about a bionic bee or a $6 million bee. I'm talking about the little old common everyday honeybee that we see in the field flying around us. Now, let's assume that we've already figured out the plans for its legs and its thorax and its head, its abdomen. We're not even going to consider how we're going to make this thing fly. According to science, the bee's body, the honeybee's body, is too heavy for it to get off the ground. But scientifically, it should not be able to fly, but it does. So we're going to say, okay, we already figured out how to get it to fly. We've mastered all these problems. The thing that we want to do here today, just one simple part of this bee we're going to look at today. We want to figure out its guidance and its navigation system. Okay, so it can navigate. Our problem is, how will we have the bee find the flowers for nectar and then bring it back to the hive? Okay? That's the only part of the bee we're going to be concerned about. Its sense of smell is very limited. The honeybee doesn't smell very well. And its sense of sight and hearing is poor also. So in order to pinpoint a field that's in a distance, get the pollen and the nectar, and get it back to the hive, we're going to need something more than eyesight and smell and hearing. And we're going to make this animal very small, the size of a honeybee, it's probably about that big. We're going to have to make this animal so that it's a social animal, because it takes more than 550 bees, and they have to visit more than 2.5 million flowers in order to make 1 pound of honey. So it takes 550 bees visiting 2.5 million flowers. So if it's going to be a social animal that works together, we'll have them cooperating and working. We don't want them wasting one bee flying this way, another bee flying that way, all of them wasting their time looking around trying to come up with where they're going to find the nectar today. Where's the best field? So what we're going to do is we're going to create a couple of scout bees. And these bees, these scout bees, will go out first thing in the morning, and they'll fly around and they'll find the best fields, and then they'll come back to the hive and they'll tell the other bees, and then all the bees can go and work in that field today. So, first thing, they've got to know which direction they're going to fly in. Well, here's a basic guidance problem. How do you tell them which direction to go? All they have to do is navigate by keeping a fixed angle in relation to the sun. So if they can tell the angle that the sun rays are coming in, you can say, well, just keep this angle and the field's over there. Okay, so they have to have something to measure the angle of the sun's rays. Now, some days it's going to be cloudy. So we're going to have to make it not only see the sun's rays, but polarized light rays also. Has to do both. That was a pretty easy problem to solve. But wait a minute. Did you consider that the sun is constantly moving? So when the bee got to the field, maybe the rays were at this thing. By the time they get back to their hive, now the sun's at this angle. So knowing the angle when they were at the field doesn't do them any good. So we have to build in some kind of a computer into this bee so it knows how fast the sun is moving, how fast the angles are changing, and how many minutes it's been since they've been at the field to the time they get back to the hive, so they can tell exactly where that field is, because it's all changing. Now the bees not only got to work this out, but then they got to tell it to the other bees. So let's imagine our scout bee. She returns to the hive and she's discovered a nice field of flowers. How is she going to tell her workers where the flowers are? She can't talk. We can have her do a fancy dance. The distance to the field would be indicated by the frequency and the pattern of her dance. The faster she dances, the closer the field. The slower she dances, the further the field. Okay? But the real interesting thing about the honeybee, the dance, communication dance, the interesting thing about the honeybee is how she gives directions. So not only is the speed and the frequency of the dance, but she tilts her body to the angle of the sun's rays to measure the location of the field. If the field was 30 degrees, the sun's rays were 30 degrees, when she does her dance, she tilts her body 30 degrees. So all the other bees know that's where the field is. Even more remarkable is the fact that during the dance, the bee will adjust because the sun is changing. The degrees are changing. And so she compensates for that. Not a problem. She just says, okay, I was there a half hour ago, now it's going to be like this. And she dances to let them know the way it is now. And the interesting thing is, all this takes place within the dark beehive where they can't even see the sun rays. If we're going to create this, how would we do that? How would we teach the bee to do these kind of things? We'd have to have them go at least 12 years of school and then on to some college. Who taught the bee to compare the sun angle to the number of degrees from true vertical to determine the location of the field? And how did this little creature learn the concepts of distance and time and direction? And then to take all this and compare it to the angles of the sunlight. And if by chance one of these animals, one of these bees came up with this idea, how would she get the others to understand it and to follow it? It's mind-boggling to think that just happened by chance. But there's more problems than that. Let's say that the dance indicates that the field is 1 mile away. How is the bee going to know when it traveled 1 mile? It's flying. Come on, aren't we there yet? I must have gone 10 miles, it feels like. Right? How are they going to know 1 mile down the road I've traveled 1 mile? Well, we could put, like a car has an odometer in it, and it records the mileage. But that wouldn't work for a bee. Because air distance and land distance are two different things. It's easy with a car, you can tell how far you went. But in the air, it's like, same like in water. If we had a boat, if there's no current, and we paddle our boat for, let's say 5 miles an hour, and we go for 1 hour, well then we'll be 5 miles from where we started. But let's say there's a current, and the current's going at 5 miles an hour toward us. And we do it for an hour, and we look out, we're going to be the exact same place we started. We didn't go anywhere, because the water's moving. And if the water was going the other way, we'd end up way past our point, because the water's taking us further. And it's the same way with the air. So when the bee's flying through the air is moving. So we have to have some way of compensating how far the bee is gone, depending on the airspeed, depending on how much the wind's blowing. So we'll have to have some kind of an air speed indicator so the bee knows when he's gone 1 mile and compensate for the speed of the wind. The bee will have to not only know the wind speed, but it's going to have to know the wind direction too. Because if it's a tailwind, then you got to subtract it. If it's a headwind, then you got to add. So he's got to know when he's flying whether the wind is at his head or is it tail. What about if it's a crosswind? He's flying along and the wind's taking him this way. Well, we'll have to have him compensate for that too, because his atmosphere is moving. She'll end up over there instead over here. Not my fault. I went the right way. I went the way they told me. It's the wind blew me over here. No excuse. Get there and work in the field. That's what they do. The other thing is, the wind's not constant. There's gust of winds that come along, whirl around in all different directions as the bee's flying. It's not a constant wind. Not a constant speed, not a constant direction. But that's we'll just have to build this into our navigation system so the bee can calculate that out of there as they're flying. Just one more thing that we have to consider. Now, picture that the scout bee went out to the field, found the field, and is returned to the hive. Do you think that that bee went in a straight line right to that field? What about trees? What about buildings and stuff in the way as it's flying? Mountains. She doesn't fly a straight line. She flies a crooked path, whatever she has to do to get back to the hive. And then when she gets back to the hive, she communicates the direction and the distance based on as if she'd flown a straight line. As if she'd flown something that she never did going and she never did coming back. She never went that way. But she gives them the directions as if it was a straight line there. Now, I'd say that's quite a remarkable achievement for that little bee, don't you think? Be able to figure that all out and do that and communicate it. Somehow she makes all these trigonometric calculations for her fellow workers. I don't know how many of you took trigonometry, but when I took trigonometry, I had tables, books. Probably now you use calculators, but I had to go in the back of my book and figure out. We didn't have calculator. I could use a slide rule, but that's all I could use. I had to use the tables, books full of tables, and logarithmic tangents, cotangents, sines, cosines, square roots. We had to figure all those things out. So does the bee. Not only does she have to figure it out, but then she's got to communicate it to her co-workers, who then are going to fly that same dog-legged path over to the field. They're not going to fly the way she said. They can't. You can't go through the trees and through the houses. And they're dealing with the wind and all the problems that we mentioned. They calculate the angles, the wind drift, the velocity, the obstacles, the movement of the sun. and they come out in the right place. And then they've got to remember it all because they got to get back tonight to their hive. And so they got to remember all this stuff during the day when they're at the field so they can get back to the hive tonight and bring the nectar back to the hive. Which, you remember, when they come back, it's going to be a different wind direction, different sun angles. Everything's going to be different. But it won't matter. They're going to have to take that into consideration when they fly back. They're going to base it all as if there was no wind, as if there was no change in sun angle, as if there was no obstacles. What would happen if the scout bee, when it was doing the dance, leaned a little bit too far, or not quite enough, one way or another? What if you went a little bit too fast or a little bit too slow? Everything's got to be just right. And it always is. It's always just right. How come? How could you design a little bee to do that? Just think of what we got so far. We've got the internal clock that'll keep accurate time. We have the polarized light sensor, the sun degree angle computer, instruments for measuring true vertical and how many degrees you're off from true vertical. Oh, one thing I didn't mention, beehives aren't, when they make their hive, they don't make it perfectly level. The beehive could be on the side of a hill. So when she does her dance, she calculates for that as if she was dancing on a flat surface. So all that's calculated in when she does her dance. So we have we need dead reckoning equipment, we need wind speed, wind direction, all the trigonometrical calculators and tables, airspeed, ground speed. Well, another thing we got to consider. There's a tailwind. You say, well, that'd be okay, they'll get there quicker. But what if there's a big tailwind when they get there? They get there and they try to get home and there's too much wind and they can't get home. That's no good. That wouldn't work. So not only do they have to know the wind speed, but they have to know what the weather's going to be. When it's going to be a storm, bees don't come out. They don't go out in the field if there's going to be a storm. So they need an accurate weather forecaster to know whether it's safe to go out in that field today. So we'll have to build that also into their guidance system so they'll know when to go to work and when not to. And we're going to make the whole thing this big, remember. Now that we've mastered its navigation system, we said we didn't know how the flight mechanism worked. It shouldn't fly, but we've got that too. But now we've got it to fly and we've got its navigation system down. What good is it? Well, we'll make it into a nectar gathering machine. And we'll put all the necessary equipment into this little bee so that when it goes out to the flower, it can gather the nectar. And then we're going to make it also its own truck. You see the farmers, they have a machine for cutting the corn, and then they have a truck that blows the silage into the truck or something. We're going to make this little bee not only the machine that collects the nectar, but it's going to be its own truck. So once it's collected it, it's going to take it back to the hive. And then we're going to make it into its own factory, and we're going to build in the necessary equipment into this little bee so that it can take this nectar when it's back at the hive and make it into honey. I don't know how we're going to do that. We don't know how to make honey, but the honeybee does. So we'll just build that equipment into the honeybee so that it can make its own honey out of the raw nectar. I haven't even started to talk about the animal itself, the nervous system, the circulatory system, the respiratory system, the reproductive system, all the other systems that have got to be built into this little animal. Yeah, I'm no quitter and I don't give up easy, but I think it's safe to say we couldn't even begin to create even a simple little honeybee. There's no way we could even start. Man, with all his wisdom and ingenuity, cannot even begin to come close. And then you're going to tell me that all this happened just by chance. Nobody designed it that way, it just happened that way because that's the way it had to happen. I don't think so. I'm not going to buy that argument. Just like you wouldn't accept the fact, even with the 52 cards, that they were all in order. You say, nah, you did that. There's too much design to that. That couldn't be random. Well, I say this can't be random either. There's too much design there. There's too much intelligent thought that's gone into something like this than to say it's just happened by chance. The fool hath said in his heart, there is no God. Think of the number of animals on this earth. And each animal has its own unique way, the own unique thing that it does. Each one showing a wise creator behind the intricacies of nature. It's not just with the bee. Solomon said, go to the ant, thou sluggard. Consider her ways and be wise. We could take the ant just like we took the bee. I don't have enough time, I'm not going to do that. But just briefly, let me mention one ant, the leafcutter ant. It's got amazing social organization and food gathering ability. The leafcutter ant will cut down a leaf and carry a leaf back to its den or nest, whatever you call it. And the leaf can weigh up to 100 times more than the ant weighs. Now, I'm about 200 pounds. If I'm going to lift something that's about 100 times more than me, that would be 2,000 pounds. That's 1 ton. So if I need a ton of gravel, instead of getting a half-ton pickup and loading it once and then coming back and getting the second load to get a ton of gravel, if I was like this little ant cutter, this leaf cutter ant, I'd say, I'll just throw the ton of gravel in the sack on my back and I'll carry it home. That's what the leaf cutter ant does. 100 times its weight. And then when it gets it back to its nest, it doesn't eat it. Because once it eats it, it'll be gone. The leaf cutter ant is an amazing organic farmer. They take the leaf, they chew it, mix it with their saliva, spit it out, and let it grow fungus. Just like mushrooms. We eat mushrooms, the leaf cutter ant eats the fungus that it grows. So it grows an organic fungus garden. And it will drill holes to let air and light in. If it's hot, it drills more holes to get more ventilation. If it's cold, it plugs up the hole so it gets less ventilation. Who taught the leaf cutter ant to be an organic farmer? How did it learn this? How do they all work together and do this? Go to agriculture school, go to Aggie school and learn all this stuff? All these growing chambers? And if one of them learned it, how did the rest of them? How did it teach the other ones? How come they all know it? How come they all work together on it? Go to the ant, thou sluggard. Consider her ways and be wise. It's only the fool which has said there is no God. The heavens declare the glory of God, and the firmament showeth his handiwork. There is no speech nor language where their voice is not heard. Their line has gone out through all the earth, and their words to the end of the world. Paul says in Romans, for from the very creation of the world, his invisible perfections, namely his eternal power and divine nature, have been rendered intelligible and clearly visible by his works, so that men are without excuse. Professing themselves to be wise, they became fools. They're too smart to believe in a God. You don't believe in a God, make it. So professing themselves to be wise, they become fools. For the wisdom of this world is foolishness with God. Indeed, when we look at nature, whether the intricacies of nature or the whole big picture, it is absolute evidence of divine creation.